All right, I guess we're live. Okay. Looks like we're live. Somebody gives me thumbs up if you can hear me, and if you can see my screen. Let's see if the chat is up. All right, I'm not some more live. I see some people giving me the thumbs up. They can hear me. All right, let's get going. Okay, so today's session, we kind of tested a few different sessions over the weekend, just testing the streaming pipeline, testing all the integration with different platforms. So today it's a more kind of production stream. So today we're working on deploying Langflow into the Kubernetes cluster with the Helm chart that we created in the last session. Okay, so that's a mouthful. Okay. So what is Langflow? So Langflow is, let me just put it on the screen here. Let's go to the website. There you go. So Langflow is agentic AI tool. It's a tool that allows you to build agentic AI with visual interface. It has a nice GUI. You can drag and drop things. You can even say drag, drop, and deploy. And this tool is open source. And we want to deploy part of our Kubernetes product. And we want to deploy within our Kubernetes cluster to manage our Kubernetes workflows and also additional business workflows, agentic workflows. Okay, so that's the idea here. Now, Langflow does have a Helm chart. Now, they had some issues with the Helm chart, so we decided to create our own Helm chart. They did a good job to start with to kick off the Helm chart. We just kind of made a little bit more production ready. And let's actually review that Helm chart before we start deploying it. Let me look at the chat here. All right. So multiple screens here. So if I'm looking to the other side, I'm just looking at the chat window here. All right. Oh, we have to introduce ourselves? Okay, great. Okay, so my name is Patrick. I'm from the Kubernetes team. Who am I? Well, I'm an engineer. So by schooling, electrical, computer, by education, software. So I'll try to cover all different types of engineering. And I'll be your guide today, okay, to deploying production-ready Helm charts within Kubernetes cluster. So this is we're going a little bit of a journey here, creating production-ready software, okay? Okay, so here's our Helm chart that we did last time in our Helm repo. And let me see, where's my diagram here? I still have a diagram here somewhere. There you go. There's our lovely diagram. So we try to kind of capture everything possible in a Helm chart. Again, we'll take the approach where we embrace the complexity in a Helm chart. Okay, we want to deal with as much as complex as possible with the Helm chart, so then we don't have to deal with it after we need to deploy the Helm chart. Okay, so we try to put as much as possible all the stuff we potentially might need in a production environment into the Helm chart. So as you can see, there's lots of different digital assets or Kubernetes manifest files here that we have. Essentially, the Langflow IDE Helm chart is made up of two components, front end and back end. Front end is just a simple deployment. Back end is stateful set. And the front end is obviously the GUI application. It's a React application. Then the back end is just a microservice there. So we kind of package all that stuff in the diagram to a Helm chart, the Helm templates. And you know what? A lot of times, before I start using the Helm chart, I like to do like a little bit of a quick test, small test of the template, all the templates that are there. So we have our templates here, and the quickest way to kind of see if the templates are okay, just render them. Okay, you can just render the templates and see, look at the output quickly. Just a quick smell test before you start using it. So let's do that. So we have a little bit of a make file here to help us to deal with some of these things. And let me just run make template here to generate the template and just have a look at the template. Excellent. I'm just going to go through the top. There we go. Okay. All right, so service account looks good. So it's using default values. I didn't provide any values, so it's using the default values. I'm just looking at the structure of the name, the labels here, properties that were set. Just a quick smell test to see if there's any issues here. We have services here, the service for the front end, looking good. And the ports are okay as well. Selector is good as well. It will attach to itself to the front end deployment. There's another service here. So this is the headless service. This is for our stateful set for the backend. You can see it's headless. It doesn't have a cluster IP. It's just for pod-to-pod communication. So pod communication between the different backend pods. And then we have another service here for the backend. This is so the front end can talk to the backend. It looks okay. And it's attached to the right component. There's our front end deployment here. Just again, picking at the values here quickly. The labels look good. We have our label here for the network policy. We'll have to check that in a second as well. Yeah, pod anti-affinity, we're starting with that. If you don't know what that means, it just means that in this specific case, we'll try to deploy that specific pod on separate, nodes, so they're not co-located, right? So you want to avoid co-location. Now, this is not required. This is preferred option. So this is a kind of default option. So we prefer that the front end pods are not on the same node, right? This is just a preference here. We can make a really strong, hard affinity when we say, it's not just about a preference, but when you're actually deploying, scheduling the pods, it will force it to go to different nodes. It's just, again, it's co-location. So that gives you a bit of, redundancy, a bit of high availability, maybe fault tolerance, all these different kind of good things. So that we're going to control that during our production deployment. So, but a default, this is good as a default. So that's good. Security context looks okay as well. One thing to check is for the username. So the username, you want to match the one that the Langflow guys did in the Docker containers as well. So that looks good. All right, there's our URL to talk to the backend. That looks good as well. All right, so far so good. Probes, resources, all good. Volume mounts, we don't have any right now. That's good. Stateful set, again, just a quick overview here. Labels look good. The selectors look good. Again, same type of soft anti-affinity, just as a default. Let's have a look at the command here. Command, okay. So this is something we're gonna have to keep an eye on, because the Docker file, let me pull up the Docker file for Langflow. Where's Langflow? Just grab any Docker file here. Just going to check the commands in the Docker file. Right, so there's the command. So we have entry point and command in Docker files, and we have command and arguments in Kubernetes, right? They're not necessarily one-to-one matched the way they are. So I think I'm going to change our implementation to overwrite the entry point with maybe something like a bash script, and then the arguments will be the Python one. Okay, I'll just leave it for the end, but that's something to look at. You want to work with the Docker containers. You don't want to just overwrite them. You just want to see why the Docker container developers did things they did. So in this case, there's no entry point. There's just a command. So you just have to keep that in mind. So by default, this is going to be your entry point here. So it's not defined. Okay. All right. So that's something we're going to have to get back to a little bit later. Here, environment variables. The database configuration is good as well, I see. And we generate our required database connection string here. Again, by default, no TLS. We'll have to test the TLS version in a second to see if that's good. What else do we have here? And we just have tests set in here. Okay, I'm just going to ignore looking at the test for now. So what we can do is we can run this template again, but just enable a few things, right? So we want to test network policy. I'll just have also let's test here vertical scaling. True. Let's test horizontal scaling as well. And let's also enable, what else we're going to enable here just for testing? Pod distribution as well. I'll just enable that. And I want to also enable network policy as well. Just have a look at that quickly. Where's my network policy? Here. Okay. True. Let's run the template again. Just look from the top quickly. All right, here's a network policy that got enabled right now. Let's have a look at this. So we have both policies, ingress and egress here. Egress looks good. Well, the ports are the same. That's just coincidental because we have the container port and the service port here. They don't have to be the same. So that's just coincidental here. For egress, DNS resolution is good. And then we also allow talking to the backend or any other pods with these labels here. Okay, that's good. That looks good to start with for network policy. Pod distribution budget, yeah, good as well. You can see the front component is going to attach to that. Okay, so that's good. And there's the selector here is going to make it attached to the deployment. All right, so we will look at the service. Let's have a look at the horizontal and vertical scaling quickly. So there's the horizontal pod scaler. All right, so the target is good. So that's, the other values obviously are empty. All right, and just have a peek at the vertical scaler quickly. Where's the vertical one here? Yeah, so this is again, so the target is again the deployment, the correct name. Okay, so that's all. All right, so it passes the smell test. So let's change the backdoor defaults and then do the same thing for the backend deployment. As you can see, this is just a quick smell test, right? If the template's not working, you get an error. If something is off, you can kind of quickly see it, and it will just save you time. Just kind of having a quick peek at the templates that are generated. In this case, I want to enable again the network policy. Where's my network policy? I should probably just do Control F. Man, we have a lot of properties here. All right, let's make this one true. Pod distribution for the stateful set. Let's enable the vertical scaling for that one. Let's have a look at the horizontal one as well. And network policy. All right. Just make this a little bit bigger. All right. So this is the vertical scaler for the backend component. That looks good. Stateful set attached to the backend. The target is correct. Let's have a peek at the stateful set as well quickly here. All right, we're good. Horizontal scaling. Yeah, the names are okay. Also, the metrics look good as well using the new standard. So we do check for the different version of Kubernetes. So let me just make this lower. Yeah, so based on the semantic version, we give you different version here. Okay. So this is the one we're seeing. And this one here, which is good. So we'll handle the complexity of versioning within a template. So we can support all the clusters and the new one as well. All right, and I want to have a look at the network policy quickly here. That's the last thing. There's the network policy. Okay. So first of all, the selector is good. It's going to be attached to the backend stateful set. The DNS resolution looks good. And the ports here, again, that's coincidental. We just use the same ports for the container, for the service. And this is important, right? So we're forcing anything that wants to talk to our API backend to have this label. So this label has to be exactly like this on the front end deployment, which is slow control F here. Yeah, so we do have two of them. Okay. So right, so these are the pod labels here. Great. So when the deployment, front-end deployment tries to establish a connection, network connection with a stateful set, it will be allowed to because of this label. Okay. All right, let's go back and revert back these changes. Actually, wait, there's one more here, pod distribution. Right, okay. Yeah, that one's good as well. All right, let's roll back these default changes. All right, I think we're good. We should also do a kind of smoke or smell test of the ingress controller. And let's just have it to the top here. Here, let's enable ingress. You know what, let's look at ingress by itself. So I think I updated the make file so we can look at individual files. Yeah, specific. All right, so let's do specific file equals to templates.ingress.yaml. All right, sweet, okay. So this is our vanilla ingress. Yeah, connects the front end service. Port is good. All right, let's test enabling TLS. Let's enable TLS. True. And there's a TLS. Okay, that looks good as well. All right, so one thing that we always do is we have our own special annotations that we add. That adds certificate manager, external DNS, all these kind of different tools. Let's see if we enable that. See if, okay, beautiful. Okay, so we have, there's external DNS. It's going to be which means this will automatically configure the DNS entries for us. And there's a certificate manager here, which is the Let's Encrypt certificate manager. And we have CORS as well, enable, okay. And we always have this little snippet here to adjust some of the headers on the ingress controller, which in this case is going to be Nginx. And we just want to remove the Nginx version here, so you don't know it's Nginx, and add other things here as well. Okay, so that looks good as well. So, okay, so I think we're good for the Helm chart. Now let's start deploying it with GitOps. And back to original version. Let's see if I added anything else. Where's my charts? KPS chart, repo. We're good. All right. So for GitOps, we have a different repository. All right. Let me just close all these different things here. So we actually deployed Langflow with its original version. Actually, let me just bring this back. So from the official open source Langflow Helm charts repo. Now, it had several issues, so we kind of patched it up. So one of the patches was here, ingress patch. So actually, let me bring Langflow. I'll just go to GitHub and maybe show you how you can maybe mitigate some of the issues in that official chart repo. All right, there's my Helm chart. All right. So one of the fixes was ingress class name on the Langflow ID Helm chart. So ingress. So if you can see here, they don't have the class name here. So ingress class name, which is required, especially for newer clusters. So you have to tell it which, when you deploy your ingress, it has a name. You just want to tell it which name is going to be associated with this ingress manifest, ingress deployment. So they don't have that, right? So if you want to, fix this issues, what we did here is let me make this a bit bigger as well. We kind of used the Helm post render method here, so which deploys the original chart, plus it added additional, post rendering. Script was executed post rendering. So the way you do it is you provide a script to execute. So in this case, it was just a awk kind of quick thing when we looked for the beginning of spec section in the YAML, and then we just added the ingress class name here. So that will kind of allow you to deploy it the way it is straight from their official repository. Otherwise, you'll get an error. Anyway, so we fixed that in our ingress controller. So we're going to remove that. Now, for GitOps, we do follow GitOps methodology of GitOps practice. So first thing we do with GitOps, we branch. That's our starting point. So let's create a branch here. So there you go. So I'm just going to create a branch here. I'm just going to call it Atlantis Langflow Helm update. Because we're going to be using Atlantis as part of our GitOps workflow. All right, so we have a new branch, so we're good to go. Just close this. All right. So GitOps, in essence, is your pull request plus your infrastructure as code plus your CI/CD pipeline, or CD pipeline, right? That's the kind of definition. That's a mathematical definition of GitOps. That's the formula, right? So really, it means that you store everything in source control. You use pull requests or merge requests, and you apply them to and use infrastructure as code. And then you, for your continuous deployment, you use some sort of a tool. So in our case, we use Atlantis. So we have our own version of Atlantis that we use to deploy this. So we're going to be submitting these changes, the pull requests, to Atlantis, and it's going to apply the changes. It's going to deploy the Helm chart for us. Okay. So let's just start making changes here. So first thing we got to change is this repository. So it's going to be coming from our repository, and also I think I called the Langflow ID. Oh, let me just double check. What is the name of the chart? Oh, wrong one. Yeah, okay, so the chart name is the same. It's just the repository has to change. It's coming from our repository now. Oops, wrong one. And let me double check. I'll just confirm the repo in our Google artifact registry quickly. And just kick off a new window here and get my repo name here from a different project. Where is my repo name? Okay, you know what? I'll just grab it from Google. All right. There we go. Okay. And let's double check this if this is correct. Yeah, looks like it's the right repository and or the right region. That's the one we use here for these projects. Okay. I just want to double check it just to make sure. Once you said it once, we're good to go. Just nice to double check. All right. Yeah, so I think we're good. Looks like that's the one we've been using, and I just want to be consistent, and we're good. All right. I'm looking at the chat. It's getting busy. Okay. So any questions, just keep asking. Ask questions. Okay. All right, so let's move on. So that's our repository. That's a chart, release name, release version. Let's update that. So for infrastructure as code, just to kind of step back and look at just give you an overview of the project here. We use Terraform and Terragrunt, both of these things, right? The reason we use Terragrunt is so we can manage environments. Terragrunt is just a thin wrapper on top of Terraform. It just adds additional functionality. So in this case, the functionality we're leveraging is the functionality of environments. So in this case, we have our environments. In this case, we have prod. Now, in this case, prod is not actual prod. Prod is our dev environment. In this case, we're treating these environments as almost like namespaces. So we can kind of isolate different configuration files to a specific namespace. So if you want to test things with minimal resources, or just have a quick test environment, we would have another environment, just call it staging or something like that. Just give it a name, and then we'll have its own properties here. So in this case, we have our prod, which is again, it's not prod, it's our dev environment. It's just trying to test it in our dev cluster, and it just has common dev specific or production specific properties here in this kind of Terragrunt file. And we also have a global Terragrunt file for all the environments. In this case, we define kind of the basic things you need to for Terraform, things like the remote state, things like the versions for your your different Terraform providers, and then in configuration for your Helm and Kubernetes providers, right? So you can connect to the right data cluster in this specific case, and Google as well, Google providers. So this is kind of the project structure that we have. We have environments and we have infrastructure. Infrastructure is where we have pure Terraform code, and environments is where we define our Terragrunt structure here with different environments. We also have this env file here, which has all the versions here. So it's just kind of extracted those versions from the comment file, so it's easy to kind of manage these versions here. And there's a couple other things here, service account, things like that, right? So you can kind of come in here and quickly change it. Okay, and for infra, again, this is just pure Terraform code in here. And in this case, it's Terraform using Helm provider, because we're deploying a Helm chart. Now we also have this data section here. So we do have multiple infrastructure as code repositories where we define the infrastructure, the foundation for Kubernetes product and for any kind of cluster deployment that we do. And then we treat almost the Terraform state as a database when we query different things. For example, in this case, I'm grabbing information from the cluster here, observability information. This is Prometheus. That's from observability repository, so I can add observability to this deployment. So they're all kind of spread out, all different packages where we can kind of develop them in kind of isolation, and then when people need them, like if you need observability, you can just query that Terraform state and bring it into your Terraform code in here, start using it, right? So it gives you a way to kind of modularize things. You don't have to have one monolithic project. I mean, Kubernetes is a big beast. It requires lots of it requires a big foundation, from security to observability. There's also infrastructure foundation as well. You want to keep them separated, and then put them in its respective state, and then use that state when you need to. So then you can also kind of isolate things between teams as well. So that there could be your platform ops team, which is kind of deals with the foundation of the core parts of Kubernetes. And then when your DevOps team that deploys application doesn't need to worry about that, they can just query that state and just use it. Okay, that's the idea here. All right. So patch, we don't need to patch anymore. Well, let's start with the values YAML. That's the best place to start. All right, so this is the original values YAML. I'm just going to grab the one from our Helm chart and use it as the default, and we can start customizing it. So where's a big values YAML here? Yeah, I'm just going to override everything here. So Langflow, the original chart, gives you the ability to deploy with an external database, which is right now, I think Postgres is supported. I think if you look at the Python code, it only supports Postgres. But also SQLite. Now, we're not using SQLite. We're using Postgres in this deployment. And we already have a Postgres deployment here that we did. So that's going to be the external database that we're going to be using. It's deployed in the same namespace. And it uses a lot of kind of the infrastructure that we already deployed in the cluster. So things like security manager, PKI, certificate manager. So we want to when we deploy things in a cluster, it doesn't matter what the cluster is. Excuse me. We always care about security. I mean, security is default. Security standard. It's not something we add after. We always start with security, right? So it's nice to have all the security tools deployed as a foundation in your cluster already, so you can just kind of use them. So in our case, when we deploy Postgres here, we use external secrets manager to already kind of create secrets that grabs the secrets from a vault, from our password manager, from our certificate manager, and kind of creates those things that then we can kind of inject into our our Postgres deployment here, and kind of manage secrets outside of your your Git, right? Because last thing you want to do is have a secret in your Git repository, right? So in our case here, we have let me see, just give you an example here. So this is the configuration here for Postgres. We customized the Bitnami Postgres chart. There's just a few issues here related to configuring with Vault, but we all kind of, once you look at the code, you'll see we'll have it here, one place where we define kind of scripts that are executed with the database first, temporary passwords, and then we go to Vault. We wire Vault to manage the secrets in Postgres. We also rotate the root password, so nobody has root password except Vault. And then so there's a workflow to deploying Postgres. I mean, just running the Helm chart is never good enough for Postgres. You have to kind of deal with security. There's just multiple things you have to do after you deploy the initial version of Postgres. You connect to Vault, and you kind of start wiring the Postgres to a Vault plugin, for example, and that kind of creates your passwords. And then once you have that, once you give Vault access to Postgres, it can then partition or create passwords dynamically for you, right? So that's what we're doing here. We, for Langflow, we're going to ask, Vault to create a password for us dynamically at runtime. So then again, so it's not stored locally. The only thing we're going to be storing locally is the name of the user, which we're also grabbing from a secret as well. So as much as possible, we'll push off, credentials, user management, all that stuff to runtime. Nothing, nothing should be statically in your code that goes in your Bitbucket, right, or a Git repository. All right, so that's our Postgres deployment here, and we'll be using that. And in our Helm chart, we actually removed SQLite. Now, SQLite is amazing. We just don't use it. So as default, we don't have it, but you can, if you grab our chart, you can just add it as a, we have flexibility for you to add SQLite to the chart, right? Which is like extra volumes, and you can change some of the values, YAML properties. All right, so this is a big values YAML. So first thing we have to do here is enable ingress, because we're going to talk to it. True. Actually, we're going to remove this from here. So I like to, when it comes to dynamic stuff, I like to move them from the values YAML to your ACL, to your Terraform code. So let's put them side by side. Oh, is Terraform state encrypted? Yes, it's encrypted. And that's part of the configuration. So you can encrypt the Terraform state, or you don't have to. You can also manage the credentials outside of Terraform with your, the same way you manage your Google bucket or S3 bucket in AWS or Azure bucket, whatever. There's credentials on top of that, but also you can have those credentials within Terraform as well. So there's many ways. Yeah, you should encrypt your Terraform state, because accidentally you might be leaking credentials into it. So you want to avoid, again, that's why we push things to to when we actually deploy stuff, deployment, because there's a tendency for people to store, obviously, credentials and Git, but also the next level is Terraform. And then if you look at Terraform state, it has credentials in it, right? So we kind of leak those credentials into the Terraform state, right? So we trying to avoid. You should obviously encrypt the Terraform state, but you want to, again, move the credentials out of the Terraform state and then just add them dynamically at runtime, right? So that's why we use things like Vault Agent, for example, which kind of injects credentials into our containers when we deploy them. So yes, we should encrypt state. All right. So what I like to do is put things side by side, so I can see my values YAML, and then I can see my well, not this main TF, this main TF. Let's do like this, side by side. Okay, so this is what I mean. I like to define ingress in my Terraform code, so it's because it's dynamic, because I need to pull in different values. So, for example, things like your certificate manager that's defined, with in a different Terraform state, different project, managed for a different team, to give us ability to use a certificate manager from Cert Manager Helm chart, and they configure for us. So we just grab it by name. Same thing when it comes to external DNS. It's managed somewhere else, deployed somewhere else. We just provide the name, and they create specific DNS records, the A records in this case, for us automatically. And what else do we have in here? Okay, so let's just adjust some of these things. So we want to enable it true, so that's gone. Class name again. So class name is something that was missing before. Let's just add the class name here. Now the class name came from. Do I still have it here? Oh, I didn't delete it. I don't want to retype it. Where's my class name? Let me just grab it from. There's my class name. So I'll have to retype it. All right. So class name was defined by the Ingress platform team. So when they deploy the Ingress platform with all the tools there, they give us the name. So let's just create a name in here. So as you can see, it comes from a remote state, Ingress remote state, and we just get the class name. So class name is gone, so that's good. Path. Let's just define the path here as well. All right, let's just delete this one here. Okay, host name. So we did define host name. So the host name here, where's my host name? So here. Let's see, that's a variable. It's Terraform variable. I'll show you the host name in a second. So the host name is defined as a variable, and it's actually set by the Terragrunt code. So host name. There you go. Just there's my variable host name. Langflow ID domain. Did I define it? No. Let me grab the right one here. There we go. So there you go. So there's the variable, and then this variable is set. Let me just close this Postgres here. It's set specifically for this environment. So it's part of the environment specific variables here. So if I look for this, just go down here. Where's my here? So there we go. Here's our domain. Now in this case, it's subdomain again, which is managed by a different team, and it's under our tech stack apps. This is on the Kubernetes project, and it's just going to have the specific URL here. We can access it. Okay. So we just inject it here on the host name. Let's remove the hosts. Path, it's going to be at the root as well. So let's have that here as well. Extra paths, yeah, let's leave that here. I'm not going to add any extra paths right now. Just common annotations. So in our case, we're going to enable the default annotations. And we're going to enable TLS as well. So I'm going to put TLS true in here. So this is TLS for us. I'm just going to remove it from here as well. All right. And we don't need all this stuff here now because it's going to be added fast. So what we have to do is replace this piece because this is generated for us in the template. So we just moved to this template. So if you go back and look at the template for the ingress controller, where's my ingress YAML? you can see, let me just move this down. Oh boy. All right, so you can see we have it all here, right? So now we don't have to define this, is define our template. And these are the common, standard things that we do. So it's nice to have it in a template so you don't have to kind of retype it all over the place. So going back to our Langflow deployment here. So this is all gone. So first of all, let me just remove this. So TLS is true. We're going to add certificate. Now this is Let's Encrypt certificate. This is for the browser, TLS SSL. And now we just need to add this here. All right, so cluster issuer, I'm just going to grab it from here. So let's encrypt. Now we have additional properties here for allowed origins. Now we allowed the default one, so we don't have additional ones. And we don't have additional headers either. And for the frame ancestors, we're going to just leave it the way it is right now. If there's any issues, we'll go back and change it. So this is about the content policy, things like that here. And so you can adjust the content policy that's coming from your ingress, what the browser sees, the first interaction with your web application. All right, so that is all good. So we can remove all that stuff. Yeah, let's remove it. All right, so this is much simpler now. So now we enable ingress, we give it a class name, we give it the host name, and we give it the cluster issuer, which is our, okay. So we can just remove this from here. So the whole section can actually be gone right now. We don't need to have it here. And then we take this variable, local variable here in Terraform, and we just add it to our values here. There we go. So we'll merge with the main template. We'll merge the values, right? So all the values will be merged and applied to a template. So that kind of makes things a little bit dynamic. So now if you make changes, you don't have to look at this. You can actually make the changes in your Terragrunt file here. You can just come in and make the changes. So change the properties you need, and it doesn't change the main TF file. Okay. Okay, let's look at the time. Oh, we still have a little bit, a few more minutes. All right, so that's the ingress. So we're good for the ingress. External database, that's another one thing that we updated. Now, we, again, allowed the certificate, the TLS for the database to be, again, managed outside of this code base. So the cluster will have it ready fast. We just have to know what the secret is. Same thing for the database credentials. They're managed outside. So those secrets will be automatically created fast by external DNS provider or operator in this case, and Vault, HashiCorp Vault Secret Manager and PKI Manager. So those are deployed in the cluster already. And we just asked them to provide us with those certificates and those credentials, which they did, and we just got to use them. So we have the name for the secret. So this is our secret here. And in fact, it's already deployed right now. So we can actually have a peek at this. And let's have a look at the cluster here quickly. Come on. Let's have a look at the workloads first. So this is the origin deployment. So Postgres, front end and back end for the IDE. And for Postgres, we have a secret here. Where's my secret here? There it goes. Database Langflow TLS. So this is the certificate for the TLS, for the TLS SSL communication. And we also have this database data here, which has the host name, password. So again, these are dynamically created with the plugin integration involved, and that specific password here gets rotated every 2 days in this case, I think in this case for this dev. So you can adjust that. Obviously, you can do it every minute if you wanted to, right? Although you shouldn't go crazy with that. So it automatically rotates this. It changes the password automatically. It creates a new secret for you, and because the secrets are mounted as read-only in your deployment, you also have to have ability to refresh the deployment, which is also another tool, which we have as well, deploy within the cluster. And here, let's have a look at this here. So it's based with annotations. In this case, we have annotations on the deployment, which tell the deployment to refresh itself. Let me just grab it quickly as an example. Where is my labels here? All right, there we go. So we have labels here that allow you to, and actually probably better see it in the Terraform code. Here you go. So these are the annotations here, not labels, annotations, where we tell it to reload based on secret changes, right? So automatically, so when the secret changes, in this case, the secret is the one that contains the database password that gets rotated automatically for us. It will also refresh the pod for us as well. All right. So let's change this whole thing. Let's just collapse some of these things. So front end, back end can. So this is for back end. For back end, we created a new external database section for ourselves. Here, external database. All right, so this is how it looks now. And it's backend is the root. So we're going to make this dynamic as well. Oh, too many. All right. So we're going to enable this because we want to talk to Postgres. The type is Postgres. The name of the credentials here are, where's the secret name? Here's the secret name. Just grab this whole thing. Secret name is here. I'll just remove some of these comments here. Let's move it back here so it's easier to edit. Okay. So we want to provide also the key for the secret. So the secret has different data elements, and we need the key for the data element. So just grab this. So this is for your. Oh, wrong one. Sorry. Let's grab this one here. This is for your host. Now this is just the key, right? So it's okay to expose the key. Not the contents of the key, just the key name. Port. Username, password, and database. Oh, wrong one. Okay. All right, so all this can go away now. Yeah, so we simplified it a lot. All right, one more thing left is to enable the TLS. True. This is going to change the connection string for Postgres. And we just have to give it the secret name for the TLS. Where's the secret name? where I put the secret name. So let's just grab it from the Postgres deployment. We should have the secret name here. Nice. This is going to TLS to our connection. Now, you always want to have TLS even within cluster pod-to-pod communication because it's a trust issue. So we always talk about zero trust, but we give too much trust to the cluster. So, we make the assumption that as long as you are within the cluster, it's safe. Well, you want to take a more pessimistic approach to security always. Start with deny all and then enable. So, taking the zero trust approach also means that the communication between different things, so, in your cluster, your pods, your stateful sets, has to also be protected as well. So when you front end talks to the back end, you still want to use TLS, right? It's very easy not to use TLS. Again, we're taking the approach of security by default. Security is a standard, and in our case, we always want to enable TLS when we do just a basic front to back communication, right? Because you can, there's a potential for bad actors to get into your cluster, port forward to your cluster, and then start snooping on your Kubernetes network and just pick up unencrypted traffic, right? So you want to avoid that. Now, at the same time, we not just practice zero trust because of TLS. We also have Linkerd service mesh installed. So if I go back into here and give you access on the example of deployment, you can see, if I zoom in, you see automatically Linkerd proxies added to these containers here, to this pod, just not a container. Also, there's an init container as well for Linkerd. So it automatically, anytime we deploy things in our cluster, we set up the namespaces to automatically use service mesh, right, for security. So Linkerd proxy here deals with a mutual TLS. So service to service communication is using mutual TLS. So that's on top. That's the TLS is on top of this TLS, right? So Linkerd does a lot of heavy lifting here when it comes to say if you want to call a RESTful API from the front end to back end, that's mutual TLS. That's going to be encrypted at both ends, in the deployment and a stateful set. So which is nice, right? So you don't have to think about it. Again, you should be aware of it, but you don't need to kind of think about it and kind of code against it. You assume that Linkerd does its job, right? And the security team did their job configuring it correctly. And then obviously we'll go back and test this once we have it deployed to see if you can actually bypass this and maybe do like a basic penetration testing quickly. In general, this is good enough to get going. It's like a basic default, basic standard. All right. So that is good. So again, we create a configured external database. We add it to the values. It's dynamic here. Let's adjust this. There's normal Langflow. So these are just resources. So we need to define resources for our containers. Now, because because the backend is Python, there's a bit of a, I don't want to say controversy, but a bit of an issue when it comes to dealing with Python microservices. So as a DevOps person, you should be sort of aware of different runtimes, Java runtime, Go runtime, Python. They all have their issues. I think Python, maybe, I love Python, but the runtime is not the greatest. And the reason is because of the threading model. So, what happens just in general when you have a containerless application, the container uses fraction of the host's CPU or computational resources, right? Or some of yours. So, for example, you have 5 CPUs on your host machine, and then you deploy a continuous application. You say use 1 CPU, for example, out of my pool of the maximum limit. Your computer only has 5 CPUs, right? So you use 1 CPU. So you give a fraction of the computation resources to the container. Now, when it comes to some of the Python frameworks, they use the CPU count to define how many worker threads you can have, right? It's like GUnicorn framework, UVcorn. And when we deploy things in Kubernetes, we don't give you like a whole CPU. We give you like a fraction of the CPU, right? So, not like a small percentage of the CPU. When it comes to, for example, Go runtime or Java runtime, they're very efficient, especially Go. It will run multiple threads on a fraction of the CPU, right? You can give it a half or tenth of the CPU, or 1/4 of the CPU, and it will just do fine. So this is very computationally efficient because the way Python interpreted has been coded, and this is all the way up to 3.12 and not 3.13. There's been some updates in the latest release, but that's not still we use in production. There's an issue with what we call global interpreter lock, right? Lock, which kind of locks the interpreter when the thread executes and waits for the thread to finish before the next thread executes. So if you use that as a as a microservice, and you have concurrent requests happening, and you use the threaded model, then you're going to have a kind of bad outcomes because unless you know that you have to give it a whole CPU to this container, to this pod, you most likely will not. And then, because you're giving a fraction of CPU, it just, the math is not mathing when you actually look at the worker threads that the server has to kind of start initially by default, right? So there's all these kind of little things you have to think about and tweaks you have to apply to Python microservices when they're containerized. Now, if you deploy on a VM, you're fine. On your computer, fine, right? But once you start containerizing it and you realize that you do have to give, some of your computational resources to the container, and that container is running a Python runtime, which is not the most efficient when it comes to using those computational resources, you might have to over-provision your deployments to give it more resources, right? More CPU, right? You might have to give it a whole CPU, otherwise things might not work well. Anyways, sorry to ramble on, but there's a lot of times from a DevOps point of view, you do have to kind of understand the application and the microservices technologies that are used and the weaknesses, so they can actually adjust it correctly. All right, well, cool. All right, so that's what we're doing here. We're defining resources here, back in front of the resources. So we just, this is a good thing to know, mention that you can define objects in your Azure Terraform variables here. And then, you can pass the whole object, and it's nice to actually use this object in your Terragrunt file as well. So you can, when you define your resources, you can package them as object, right? So in this case, for the backend, I'm giving it, 500M, which is, it's a quarter of a CPU. And we'll see how that's going to work out. So in general, I think 1900 is a whole CPU, 900 mils. And so this is like a quarter of a CPU. And the limit is 1. So it's going to go between this quarter to 1 CPU. And we're just using, these are kind of guesstimation initially. And again, we're not enabling horizontal scaling, vertical scaling, that stuff. This is done later when we start profiling applications. So this is like an initial guesstimation. We'll deploy it, see if it's not enough, see if it's too much. We'll have a quick peek at at observability feedback, and then we'll come back and adjust again and redeploy it. So it's dynamic. So DevOps is dynamic. It's based on feedback, right? So it's very difficult to get these numbers correct from the start. You just sort of do a little bit of a guesstimation, you let it run, you profile the system, you look at the outputs, from your feedback loop, from your observability, and then you come back and you change it, right? And you want to make us cost effective as possible. So, you got to get into practicing FinOps, right? Financial operations, right? So not just DevOps. If we don't think about FinOps, I'll just make this, 4 CPUs. I just don't care, right? That's, because I'm not optimizing for, for the cloud bill, right? So the cloud bill is going up and up, and your managers are complaining, and then you're in trouble, right? So you got to be mindful of FinOps as well. So, that's something that you always kind of think about when you kind of getting to computation resources and thinking about what are the most efficient, cost-effective computation resources I can deploy for the application to still run and give a little bit of room here. We're not in production yet, so you don't need to worry about over provisioning or automatically scaling because there's too many users or too many concurrent users. So we're not there yet, right? That comes after when we kind of profile in production, right? So again, it's about continuous kind of delivery, continuous deployment, that type of methodology where you deploy it, you look at feedback and you can iterate and just keep on changing and updating it, right? Anyways, so make this one. Anyway, so this is our resource object for the backend, RESTful API, and this is for the front end for the React application. React application obviously is a little more efficient. It doesn't require as many resources, even if a lot of concurrent users. Then Node.js is fairly efficient when it comes to the runtime. Yeah, and Node.js is also something you should be kind of look into how it works, how it functions. So yes, for DevOps, you have to know exactly how Java, Rust, Go, Node.js, Python, runtimes work. You have to know more details as well, how they kind of function. Developers don't, application developers don't necessarily need to know that. I know they just start coding right in the business application. But we have to kind of understand that, so then we can maybe guide the application developers, also partition the systems, with the right completion resources and the right structure, right architecture. Anyways, moving on. Let's look at this here. So it's under backend resources, and then we're sending it to the backend. Okay, what's here? What did I list of strings? Nope. I want this to be like this. Okay, good. All right, released and version. Let's go back and adjust the released and version. So, actually, you did that. Okay. Are we good? It looks like we have everything ready to go. You just double check here. Oh, metrics. Let's enable metrics as well. Okay, so this is pod monitor. This is to get the metrics from the backend server. They don't seem to be metrics for the front-end server. We'll probably add that later with Sentry or something like that. So we're going to enable the metrics, enable the pod monitor. Did we test the pod monitor actually? Hold on, let me go back into, not sure if that template is okay. Let's enable it here and just have a quick peek if there's any bugs in this template. Just true, enable this. Oh boy. Oh, okay. So we do have a bug in our pod monitor YAML. Where is it? It's a good thing we checked. Line 50. Line 50? No, line what? Where is my error here? Okay, yeah, so yeah, a bit of dyslexia here. Okay, this should be backend.metrics.pod monitor. I'm gonna have to release this chart again. Oh, that's good. Damn it. Okay. Well, let's bump up the version here to 2. Let's package this. Oh, I forgot. I can just grab this this repo name from here. Let me just double check if that's the one I have already. It's good. All right. Going back to repackaging and pushing this to our repo. All right, let's push this. Version 2. Did I push it with defaults? I did. I don't like to have pod monitor as a default, especially because people when I have observability stack enabled. Oh boy, okay. Let me just have a look at this one here in the output. There's my pod monitor. I'm just double check it here. All right, so that's the endpoint. And okay, let's look at the original Langflow chart quickly. Where is it? Here. Okay, so there we go. So that's correct. So they use a scraper. We're using a pod monitor. So, but the port and the path is correct. So it matches. Okay, good. Let's move this out of the way. All right, let's go back. Anyway, so I like to, again, have this disabled by default. Let's bump up the version. We're going to come back and clean these versions up later, but just for now, just package this. All right, and let's push this. Now I'm using obviously applications here, not a terminal. It's just easier to see versus me typing commands, so you can see what I'm doing. Let's push this. Okay, we're good. All right, let's update the version first thing before we forget. So in Terragrunt, we have a version here. So now it's 3. Okay. And let's define, I'll leave it in the values YAML, just for now. When we need to make things more dynamic, like the namespace or the interval, things like that we can then bubble up to the Terragrunt configuration, so it's easy for us to change, then I'll change it. Right now, the defaults are okay. I just want to know if it works, if the pod monitor collects the data from the backend deployment from a stateful site. If it does, then I'll see what it is, and I'll tweak it. Probably adjust the, actually, wait, no, hold on. I take it back. We have to adjust the labels here so we can match the right Prometheus deployment. Okay, let's see if we have, yes, so we do have Prometheus deployed here, data, remote data store. So we're pulling the Prometheus. So we need to get the labels from here. So let's do that. So we're gonna set these values, dynamically here. So I want to set metrics pod monitor. Let me just put this in a split window here. So backend the metrics dot pod monitor, and we're going to set the labels. Actually, no, let me grab this from different releases because this is a standard thing we do. We don't have to kind of we use this often. Whereas just pick any other deployment quickly. All right, let me just grab it from OpenCost, for example. There we go. All right. So we use the same observability stack with the same labels. So in this case, can define, just replace this here. Okay. And all right, so let's just explain what we did here. Let's have a comment here. All right, so what we have here is labels. Okay. Now these labels are used with, this should say pod monitor. Damn it! That's why we copy paste. Okay, we'll have to mental note. We're gonna have to adjust some of these comments here in the chart. Pod monitor. Okay. So when you want to kind of wire the service monitor, the pod monitor to your Prometheus deployment, it's based with labels. Okay, so you got to match the labels of your Prometheus. So we expose the Prometheus labels, so then we can use it, during this deployment, and we can just adjust the labels. As you can see, this is a JSON object. So if you look at here, we're going labels dot, and this is the the key. So it's not a JSON object; it's a dictionary. I meant to say. So it's a dictionary. So in this case, I'm adding a key, and then I'm adding the value. So for this key, okay. So this is going to basically adjust the labels for us to match to the Prometheus labels that are exposed in your observability stack. Okay, so that's good. So going back to, so we need the labels here anymore. That's gone. And let me just double check if I use labels or selectors in the Helm chart when we did. I usually like to use labels for consistency, but let me see what I actually did. Where is my labels? Huh, interesting. Did I make more mistakes here? Oh. Okay, well, let's update the labels here as well. I'm just going to grab my previous version. Did I make mistake in both places? Looks like it. That's interesting. I see what I did. Okay. So labels here. So these are the labels, and the selector here should be the selector. Okay. So, all right, let's bump up the version again. Number 4. All right, so here, what I'm gonna do is I'm gonna put the labels here, and the selector is gonna be the way to select the Prometheus version based on labels, and the labels will be part of the labels that we add to the pod monitor labels. That might be convoluted, but I'll show you what I mean in a second. So I'm just grab it from my service monitor quickly. So I'll make more mistakes. All right. So I'm going to combine the pod monitor labels and the common labels into these labels. All right, good. Okay. So there you go, labels. Again, these are the metadata labels versus the selector labels that we use to select the Prometheus instance. So just going to be consistent now. Anyways, let me just double check these labels. This is my label variable here. I'm combining both the pod monitor labels and the common labels that we have They'll keep on adding to everything. Annotations are good as well. Okay, good. And then we get the custom labels, and we pass labels. That looks good in the template. And now let's adjust the selector, which will actually use the labels to attach to Prometheus. Where's my selector labels? So let's combine. There we go. Okay. I think we're good. Let's double check with our values. So metrics, pod monitor, and then we have labels and selector. I think I'm going to adjust, again, the comments in here. All right. Look at all the other comments I added here. Port is fine. Metrics, path. Namespace is okay. We don't need to add this. I think we're good for now. All right. Right. Yeah, 04, bump this up. Monitor. Yep. So we're good. We have the labels here, and we have the selector here. All right. All right. I think we're good. Let's package this. Somebody's asking about TLS. Yeah, TLS everywhere. Zero trust. We don't just say zero trust. We got to practice zero trust as well. The trust is vulnerability. You remove trust from any system as much as possible. Again, take that pessimistic approach. Deny all, and then just enable things as need to enable them. Okay. All right. Moving on. So now let's bump up this 4 and this 4. And I'm not going to add the extra labels, but I'm going to add the selector. So I can select the right Prometheus instance. So going back into the main, this is going to be selector. Okay. You can remove it from here. Oh, let me double check the template here, see if I made any boo-boos. No, we're good still. Okay. All right. So I think we're good to deploy this. Okay. Just double checking everything. All right, let's do the GitOps thing now. Okay, so we have our changes in our branch. Let's create a pull request, and let's see if Atlantis notices any issues. Now we need to update the README as well. So we do have a README here that's automatically generated. It could be part of a Git hook. I think it should be. In this case, I'm just going to do it manually here quickly. What I call it, docs generate. Okay. All right, sweet. So right, just going to give you a description of the variables and different, and outputs. There's no outputs here, but the variables are Terraform variables are defined. It's nice to kind of look at them in your Git and your Bitbucket when you're looking at them. Okay. So let's follow GitOps here. So going back to our, let's commit these changes before we forget. All right. So we have our changes here in our branch. Let's commit these changes and create a pull request. Before we do this, just have a quick peek. Yeah, we changed this. Main. We changed the ingress. We did change external DNS, external database. And we did change the Helm chart here to go to our Helm chart. And we attached the Prometheus selector. Okay, good. Values, oh, they're just too crazy. You know what, let's do full name override as well. So I always like to control the name of the different different assets, digital, or different kind of things you create in your cluster. So yeah, let me do that. So last thing, we do have a variable for full. Do we? No, we can just do it straight in here. So name. Yeah. So full name override, and I don't like to pull it from here. We should have a Terragrunt variable here somewhere. Where's my full name override? Did I add it? Okay, let's add it here. So we can okay, let's do it. Okay, so let's add a variable here quickly. There's no full name. No. All right, so quick variable, full name override, description. Oh, come on. All right. Let's put in a Terragrunt default here. So we're going to call this Langflow IDE. Langflow IDE. Okay. And then we can just add it here. All right, there you go. So we can't easily update it. All right. All right, getting back to our GitOps. All right, so we have a branch. Let's get ready for pull request. Just commit these changes here. Langflow deployment with Kubernetes chart. If I can spell updating correctly, okay, there we go. All right. Let's push this branch. There we go. Okay, now every Git provider has a different way of doing it. GitHub has its own way of doing it. GitLabs as well. I guess in GitLabs we call it merge request. We're using Bitbucket here, so I'll try to do a Bitbucket quickly here. Where is my Bitbucket? There's my Bitbucket. All right, so I'm just going to go to the repository, Langflow, pull request. Let's create a pull request here. And I'm just going to delete the branch after it's done, just so so you can nicely clean up the branches. Now we are using trunk-based development here, so that means that the trunk is key, or the trunk is king, I want to say. So the master is king, so to speak. So we don't have long-running branches. They're very short-lived branches just for development. So for CI/CD, DevOps in general, anything to do with CI/CD, trunk-based development is sort of best practice, I would say, versus using other kind of good methodologies when you have hotfixes, other branches, right? It just becomes much easier just to always go against the trunk in your CI/CD pipeline. Okay, you don't have to. It just makes life much more easier. Anyways, let's just have a quick peek at these changes here before we create the pull request. Okay, I'm just going to create the pull request. So we should get quick feedback in our Slack. So we do practice chat ops. Where's my Slack here? So we have a way we can see feedback from Slack channel here. So you can see these are my changes here. I pushed. And see this Atlantis. So I can just do things here. Bitbucket has a bot here, Slack bot, so I can actually interact with it here. I can just do replies here. So I don't have to go to Bitbucket, but let's just go to Bitbucket. Anyways, you can see the feedback here. Again, DevOps is about feedback loops. This is another feedback for myself, for the team to know that something's happening. Somebody did a pull request, and we have all these hooks executing here, Atlantis hooks before the Terraform, before it's running the Atlantis plan, the Terraform plan. So if I refresh this right now, we can see that Atlantis executed the plan, Terraform plan. There's a couple workflow hooks that we have, security hooks here. You can see that we get some feedback from infra cost here. It needs to be updated. We're on the older version right now, but you can see how much it will cost. Right? So we have lots of kind of different plugins in Atlantis to kind of give us quick feedback about what's happening here. Anyways, so what I can do right now is just to deploy this, to apply the changes. So we did the plan. The plan looks good. I can apply it. I can just do a comment here. Now just remove any formatting here. And just applying the comment here in your pull request will force Atlantis to apply this. And the way it knows how to do this is if we go back to the project, we have Atlantis YAML here. And it just knows where the files are, which project there is, and how to kind of get that once it does a pull request and grabs the code. All right, so if there's a failure here. Okay, beautiful, good. Let's see if we can learn something from this failure. Let's reload this. All right. So we have an issue with the Helm repository. Okay. So it's forbidden right now. So the service account that's used with this deployment doesn't have access to the Helm repository, which is good. Again, zero trust, right? We deny everything, and then we just kind of slowly kind of release the hose, keep on adding it. So let's add this. Now we're gonna have to finish soon. So let me do this as last thing. I see people pinging me. So just to kind of explain the issue here. So when Atlantis executes Terraform, it uses a service account. It impersonates another service account, right? So we have this kind of hierarchy of service accounts. So then we don't have to kind of bake in all the roles and permissions to one service account. So then the service account that's required for specific deployment has all the features or permissions that it needs to have, right? So in this specific case, the service account that we use with this Terraform deployment does not have these specific permissions. So when Atlantis impersonates that service account and uses those permissions, it doesn't have access to the to the Helm repository. You can see it's forbidden for 3, right? So we just have to update that specific service account and I'm looking at my clock quickly. So let's just do this quickly. So so where's the service account? So here's the service account here. That's the service account name. Now the service account is, again, it's managed by a different team. And let me go to that Git repository quickly and just and I'll show you what it is. I'm not going to apply it right now. Probably leave for another session. Where's my service accounts here? So this is managed by the security team. Let's do this quickly. All right, just bring this on the screen. So these are the different service accounts that the team manages. Again, it's not through GitOps, so you can see it, and it's done with code, infrastructure as code, so you can easily see it. You don't have to go to the Google IAM web application or use Google Cloud commands. You can just see it here in this YAML. So in our case, we need access to the Helm service artifact registry, that specific repository. So if I go back and get the name here, so this is the name we're using here. So this is the service account we're using. So let's just go back. And I do have to run, but I'll show you what it is, and I'll apply it next time. Anyway, so this is what the roles that we have in here. Let's see if there's a required role that we need here. So we have storage container. I don't see artifact repository here, which means this the service account does not have access to the artifact repository. Okay, so we just have to add it here, apply it, and then just ask Atlantis to apply it again. Let me just quickly see if I can grab it from, do I have it here anywhere? I'm gonna have to actually find the name of it. What is the name of this? All right, let's end it here. Anyways, so once we apply this, we'll finish the GitOps process and allow this to finish. Let me look at the comments here in the chat. All right, great. Since we do have to run, I'm going to be ending here. And now, if you have any questions, issues, comments, if you want to roast me because of something you saw, it's incongruent with the way you do things, just throw in the channel. There always should be a reason why you do things. So we should always kind of explain why we do things. What is the reason behind it? Anyways, I just see artifact registry here. It's right in the middle of the screen. So you're just missing that one. Anyways, so thanks a lot. We'll see you guys next time.